In the previous section, we have seen that for simplification of Boolean expression by Boolean algebra, we need better understanding of Boolean laws, rules and theorems. During the process of simplification, we have to predict each successive step. For these reasons, we can never be absolutely certain that an expression simplified by Boolean algebra alone is the simplest possible expression. On the other hand, the MAP method gives us a systematic approach for simplifying a Boolean expression. The MAP method, first proposed by Winich and modified by Karnaugh. Hence, it is known as Karnaugh map, KMAP. The method involves a diagrammatic representation of a Boolean function. This representation is called map. The variation on the construction of this map that was proposed by the Karnaugh is used in an n-variable complete Boolean function is represented by truth table. Since each variable has the values of 0 or 1, the truth table has 2 to the power of n rows. Each row of the truth table consists of two parts. First one is an n tuple which corresponds to assignment to the n variable, and second one is functional value. A Karnaugh map is a geometrical configuration of 2 to the power n cells such that each of the n tuple corresponding to a row of the truth table uniquely locates a cell on the map. The functional values assigned to the n tuples are placed as entires in the cells. Thus, for any n tuples in which the functional value is 0, a 0 is placed in the associated cell, while 1 are placed as a cell entires for those n tuples that have functional values of 1. In this way, the Karnaugh map becomes a diagrammatic representation of a truth table and correspondingly a diagrammatic representation of a Boolean function. The KMAP is a matrix of squares. Each square represents either min term or max term from a Boolean equation. The arrangement of the matrix square performs identification of input variable redundancy, which helps reduce the output equation. The KMAP identifies all of the cases for a given set of input variables where group of minterm may contain redundant variable of the using KMAP expression with 2 or 3 or 4 variable are easily minimized. The basic of the method is a graphical chart. Now it contains boxes called cell. Each of the cell represented by one of the 2 to the power of n possible product that can be formed in variables. In the KMAP, if you divide, what are the procedure we have? Mainly, the KMAP can be derived in a 3 portions. The first portion, we can say that KMAP, we can make identified the steps. In the identifying steps, we can represent from the truth table what are the values of 1 and 0 present that we can doing with respect to the KMAP. Second one, we have to make grouping the cell according to the 1 and 0 present. Finally, we are simplifying Boolean expression. In a single word, KMAP is nothing but we have to use simplify Boolean expression in a very easiest method. Let's see how KMAP works. How to represent from the truth table? Let's check. Now, what is KMAP contains? It contains some boxes how I have shown here. First, we are taking example of 2 variable. So 2 variable means it is 2 to the power of 2, or we can call 2 to the power of n, where n variables. The example 2 variables, 2 to the power of 2 is 4. So 2 variables, we are using 4 box as shown here. In two variables, the variable name called A and B. So we are taken the horizontal is a one variable, vertical is a another variable. You can take either MSB in vertical or horizontal. There is no rules that MSB you have to take in vertical and LSB you have to take in horizontal. You can take whatever, wherever you want. Now the first box in the horizontal we can represent something called as a B bar and B. If it is vertical, B bar is nothing but we can represent as a 0 and B as a represent as a 1. If you are going with the vertical, so A bar and A we can represent, A bar is nothing but 0 and A is nothing but 1. This is how we can represent the two variables. Here in the first box, the 0 is present here and this is also 0. So both the zeros we are calling as it is 0 in the first box. Second box, in the A bar it is 0 and B is 1. Usually A we are taken as a MSB bit and B we are taken as a LSB bit. So if I take as a and B here, so first we are taken the term 0 0, obviously we are getting as a 0. Next we are getting 0 1, so B is 1 in this case, so this box we are calling as a 1 box. Next we are going with the A is 1 and B is 0. So A is 1 and B is 0, obviously we are calling 2, so this box known as 2. And final one, A is 1 and B is 1. Both the condition 1 1, this box is known as 3. This how we can draw the particular KMAP for two variables. Any two variable, you have to draw this KMAP diagram first. This is called as a representation or creating KMAP. Once you created KMAP, now also you can create the same KMAP using expression also possible. In the expression, if it is first one, we can call as it is A bar is here and B bar is here. So this expression also known as A bar B bar. And next one, this one is A bar and this one is B. So it is called A bar B. Either we can represent 1 or we can represent A bar B also. And next expression we are calling A B bar. Why? Because this is for A and this portion is for B. So it is called A B bar. And last one, this one is A and this one is B. So it is called A B. Like that we can represent KMAP in either equation form or 0 1 form. So now how to make the truth table into the KMAP? That is called truth table representation in the KMAP. Suppose we are taken one example A, B, Y, where A is the MSB bit, B is the LSB bit and Y is the output. First example 0 0 0. So in this example A, B 0, Y is we are taken 0. Next condition A 0, B 1, Y is 1. This is A is 1, B is 0. It is called as a 2. And same way, if it is A1, B1, we call as a 3. This is what we are taken exactly here. 3 means this portion, 2 means this portion, and 1 means this portion, and 0 means this portion. Next, we will go with the one smaller example how to build using truth table to the KMAP. First condition 0 0 0. So 0 0 condition, we can write this one as a 0. Next condition, it is 0 1 1. So here we can write it is 1. Next condition 1 0 also it is 1. 1 0 is nothing but 2. So in this condition we are writing 1. And last condition 1 1 it is 0. So we are writing here 0. This is how the truth table can be represented using KMAP. This is the first step for the representation of any truth table. So if you take one more example, again here the AB 0 0 it is 0. We can take the first column 0 is 0. Next condition 0 1 is 1. So 0 1 is nothing but 1. So it is 1 means we are taking here as a 1. Next condition 1 0 it is 0, so in here we have to take as a 0. Next last condition 1 1 it is 1, so in this condition we are taking as a 1. This is how the second truth table can be represented in KMAP. Similar way, one more example you can take. In this example 0 0 it is 1, so the first one it is 1, you have to represent something 1 here. Then 0 1 is 0, so 0 1 is next case it is 1, like so we are calling this one as a 0. Next 1 0 is 0, 1 0 means A is 1 and B is 0, this condition it is 0. And last condition 1 1 it is 1, so this is 1 because A is 1, B is 1. This how you can represent two variable truth table into the KMAP. This is the first step for any KMAP. Once you have truth table, from the truth table you can represent to the KMAP. Now here one more example I have taken with picture. Just identify this. In this picture first we have 0 0 0, so we are made as a this portion is 0. Next 0 1 1 is 1, so when A is 0, that is this condition A is 0 and B is 1, we are giving 1. Next condition 1 0 it is 1, so when the A is 1 means this one, B is 0 means this condition, so we are making 1. And last one 1 1 0, A also 1 and B also 1, we are getting 0. We can represent either in the number side like 0 1 0 1 like that, or you can represent A bar A and B bar B. Previously I represented both the way. Any one way is okay for you to represent. That means either you can go with the equation form or either you can go with the notation 0 1 form. Next we can move on the KMAP for the 3 variables. For 3 variables means how many cells required? It is 2 to the power of 3, so total 6 variable we require. We can make that first 6 variable to the map. First we can have truth table. In truth table we have 8 conditions. Each condition we will call one particular value. For 0 0 means we know that it is 0 value. If it is 0 0 1 means it is 1. 0 1 0 means it is 2. 0 1 1 means it is 3. 1 0 0 means 4. 1 0 1 means 5. 1 1 0 means 6. 1 1 1 means 7. From this notation we can draw the KMAP. Already I told KMAP 3 variable means 2 to the power of 3 means how much? 8 boxes. So 8 boxes required. So first draw the 8 box. Here as it is first 2 variable how many box written, we can try from that. So if you write as a box, first we can take as a LSB bit into the horizontal form and MSB bit into the vertical form. So it is called B bar C bar, and first one is we are calling as a both are 0 0, and next condition it is B bar C, and in the vertical we are taking variable MSB bit A bar A. Okay, so we can write like that, which one contain A portion, which one is contain BC portion. And B bar C bar we can represent 0 0, B bar C we can represent 0 1, A bar is nothing but 0, A means 1. This is how we are done first bit. But here we are taken 0 here because all 3 are 0 0. This condition we are calling 0. Next condition it is 0 0 1, so 0 0 1 means it is 1. Next condition it is 1 0 0, so 1 0 0 is this condition 4, so we are taken 4. Next A is 1 and BC is 0 1, so it is 1 0 1 part. 1 0 1 we are calling as a 5, so this one named as 5. Okay, now let's go with the next portion. In the next portion we can draw with same similar way in the equation form. If you want to make it in equation form, the first one is A bar, it is here A bar, and whatever here we have to write here B bar C bar. Same way, next condition it is A bar A B bar C bar, because A is here present and B bar C bar as it is. In this portion here it is A bar and B bar C as it is. Last condition A here and BC as it is this side. This is how we can write in equation form also. This is how you have to represent first 4-bit. Next 4-bit, you can once again check for KMAP 3 variable. In this what happens, already I told that if it is 2 to the power of 3 variable means 8 cell, another 4 cell we can write. Here the thing is, either we can write 8 cell 4 in the row wise and 4 in the other row wise also. Otherwise, you can do it in 4 columns also possible. 4 column one side, 4 column another side. Then what you have to do? This side you have to take 2 variable and this side you can take 1 variable. That also works. There is no protocol that you have to take always the row is 2 and column is 4, not like that. You can vice versa also you can do it. In this condition I am taking 2 row and 4 column for easy purpose, and the row side I am taking A and column side I am taking BC. That is LSB bit I am taking column side and MSB bit I am taking row side. So here one more condition is very important. Any adjacent side if you want to do it, in this adjacent side only one variable can be changed. If 2 variable we are changing, it is not possible. Usually we are taken B bar C bar means the 0 0 first condition. Second condition we are taken B bar C is nothing but 0 1. Obviously you think that next part is 1 0. But here if I take 1 0, what happens? B also it is different and C also is different. If both the variable is different, we cannot make that one as a adjacent. But 0 0 0 1 we can make it, because 0 0 this one is common. Only one variable is 0 1, it varies. But in the second case 0 1 1 0, both the variable are varying, so I cannot take 1 0 in this condition. So here we are taking as a 1 1 condition, so that is called BC. So BC, why? Because very important in the KMAP. Almost everyone confused with that. The BC taking only that, the only one variable, the C is common here, B only changes here. The KMAP rules is that you have to make such a adjacent cell which is one variable is common, another variable is varied. For that reason we are taking the third column is BC. If you take this column as a BC, the reason is the B bar and B is a variable and C is a constant one. The main rules of the KMAP is that one variable should be common and another variable should change. If both the variable is changing, then we cannot do KMAP adjacent side. For that reason we are taking, instead of here BC bar, we are taking BC. It is very important part in the KMAP. Once you are done this one, next we are going with the last one, BC bar. So in this BC bar, here if you take adjacent remembrance, B is common, C is varying. So this way you can make it as a portion as BC and BC bar. And BC means both are 1 1, so it is called 1 1. BC bar means B is 1, C bar is 0. So we have the other 4 matrix or cell, we have how to fill this one. Now take one by one. In this column here it is called 1 0 portion and 0 is here, so it is called 0 1 0. So 0 1 0 usually we are calling as a 2. Next one we are calling as a, this A side is 0 and BC is 1 1. So 0 1 1 usually we are calling as a 3. Then we are going with the 1 from this side and 1 0 from this side, so it is 1 1 0. 1 1 0 usually we are calling as a 6. Then last one is 7 because it is 1 and here also it is 1 1, so it is called all ones, so it is called as a 7. Now how to represent in equation form? Equation form, if it is 1 we are taking as a directly, if it is 0 we are taking as a complementary form. So here we have A bar, so it is A bar. We have BC here, so BC directly. Next we have, in this case, A here and BC from this side, so it is ABC. And this one A as it is here, and this column portion is BC bar, so it is ABC bar. And last one is, it is A bar from the row side, and column side it is BC bar, so A bar, BC bar. This way you can represent the KMAP for 3 variables. The 3 variables, important part you have to remember 2 things. Either you can make 2 row 4 columns or 2 columns 4 row possible. Second point, when you are doing in the KMAP, always remember that once you taken 0, 1, then you have to take 3 and 2. It is not a 2, 3. Very important. Same way, next portion 4, 5. After that it is not a 6, 7. It is 7, 6. This portion you have to remember the first whatever 0, 1 is there, it is coming here opposite. For those reason only 4, 4 cell I have taken. Now we can take one example. First, ABC bar. In this, ABC bar is where it is present. A means this second row and BC bar means last row. So we can call ABC bar present 1 here. Next we can go with the ABC. ABC means A is anyway second row and BC is present here. So we are going with this column. So this is 1. Then A bar, B bar, C. So A bar is actually first row. So take A bar and B bar, C where it is present, this portion. So this portion is 1. Like that we are made 3, 1. Other portion simply fill with the 0. This is how we can represent from the equation into the KMAP. In the equation, whichever portion is present, that particular portion you have to make it 1. Whichever not present, make it 0. Same way, you can take one more example, the below shown. This example says it has P is equal to summation of 5, 4, 6, 7, 3. So we can easily make that 5. 5 means this is high. 4. 4 means this one is high. 6 means this one is high. And 7. 7 means this portion is high. 3 means this portion is high. This how we can make it 1. Wherever not there, that portion simply fill with the 0. This is what the representation of the 3 variable into the KMAP. If you know truth table, you can represent as shown previous, or if you know some canonical equation also you can represent, or if you know some notation also you can represent. Now KMAP can be represented 3 ways, either truth table or either canonical equation or either notation. If it is simplified equation, we cannot take KMAP because the aim of the KMAP is to make simplified equation. So other whatever form is there, that form you can represent in the KMAP. Let's try with the one more example. In this example, we are taking as a B, C as a 3 variable. And each variable operations up to 0, 0 to 1, 1. This is why we are taken just a example purpose. First is 0, so first portion is 0 because 0 into 0, 0. Next it is 0, you can write here 0. But the easy method, always remember, instead of writing 0, first write wherever 1 present and all the other else condition simply fill with 0. That is the best method to represent KMAP. So where is 1 is there here? 1 is present as shown in this portion. 1 is 0, 1, 0. So 0 means A, the first row. 1, 0 means this portion. So we are getting 1 here. Next condition, we have 1, 0, 0. 1 means A is second row. 0, 0 means this first condition. So we are representing 1 here. Then we have 1 in 1, 0, 1. 1 means A in the second row. And 0, 1 means B in the second column. So we are representing 1 here. Or last one, 1, 1, 1, all ones. So 1 in the second row or 1, 1 here. Or you can easily use another method here, the notation number. Here the present in 2. So where is 2? This is 2. You can take it. Same way it present in 4. So where is 4? This portion. Again it present in 5. Where is 5? It is here. Same way it is present in 7, so you can do it in 7. Like this you can represent the values. This is already I told, using the numbers we can represent. The another method you can represent using equations also possible. Instead of 0 you are writing a bar, instead of 1 you are writing a, and vice versa. In the 0 0 means b bar c bar, same similar way. Okay, any one you can represent, both are not required to represent. But when I am showing both the way, whichever easy to track you, whichever easy to understand, that process is practice and everywhere represent that way. The representing from the truth table, this method actually easy, but from this equation forming or equation simplification is somehow difficult. For that this method helps you more. So whichever easy for you, once you understand full KMAP procedure, then you can choose it. Now we can move on the KMAP for 4 variable. So KMAP 4 variable means how many cell required. Usually 2 to the power of n is formula. Here 4 means 2 to the power of 4 is 16 part. So we can go with the 4 by 4 ones. Okay. So already we know that 0, 1 and 4, 5 from the 3 variable. So I won't require too much deep on this side. In the vertical and horizontal 4 variable we can equally divide 2 and 2. So first MSB bit, A and B we can take in a vertical part, and CD we can take as a row part, CD as a column and AB as a row. So the first portion, whatever we have, actually A bar B bar is the first portion here, so we are taking that A bar B bar. Next we have 0 1 as a part, that is nothing but A bar B, it's all 0 0, right? Next similar CD means 0 0, so C bar D bar. Then we have 0 1, so it is C bar D. This is what truth table for 4 variables, 0 0 0 0 0 0 0 1, so on. Everyone know how to write truth table input form. The similar method we are drawn for 4, and if it is all zeros it is 0, if it is 1 0 0 0 it is 4, similar way 1 5. Already we are done in 3 variable, exactly that. Okay, then we can go with the equation form. Here equation form, A bar B bar as it is we are written, and C bar D bar here written. Similarly A bar B we are written here, and C bar D bar from this we are written. Either you can go with the 0 1 4 5 holds good, or you can go with the equation also, whichever easy for you tracking, that you can follow. Similarly this portion is A bar B. We can represent this cell also in equation form. So here first we have A bar B bar, we are written as it is here, then from the column side C bar D bar. So this particular cell is known as A bar B bar C bar D bar. Similar way we can take as a next cell. In this next cell we have A bar B, so we can write this one A bar B as it is, and from the column C bar D bar, so this portion is C bar D bar. Similar way we can fill with the other group also. Here C bar D is there, so both the column is C bar D, and this is A bar B bar, so this portion is A bar B bar, this is A bar B, so here also A bar B. The particular row and column, that particular cell equation has to be filled. From that we can say that it is in equation form or it is in notation form. This is the 3 variable, how we are discussed, exactly same. There we are only taking 3 variables, here we are taking 4 variables, but the number is same, 0 1 4 5, there also we got, here also we are getting same. Next we can go with the similar way of 3 variables, other 2 portion. In this if you are taken, that is exactly same there, 2 3 and 6 7. Here we are taken 0 1, then we have to take 3 and 2. Already I explained why we are taking 3 here and 7 here. So according to that equation, similar equation we are taken. Here CD is there, so in the both the side we have CD, and all the row this one A bar B bar. Okay, and here all the row is A bar B. This is way we can draw the equation. So in this C and D means 1 1 also we can call, C D bar means 1 0 also we can call. Now we can move on the next 4 columns, which is very important in the 4 variables. Now what may be the next this 4 cell? Already I told we have taken A bar B bar and A bar B, that is similar to C bar D bar and C bar D. Next, from the similar way, here usually we have to take after A bar B, we can take A B bar. But thing is, if I take A B bar, the issue is both the variable is opposite. A also opposite, B also opposite. This case we cannot take that one. Already I told in the KMAP the rules is very strict. The adjacent side always any one variable can be changed. There cannot be changed two variables. So this is similar way how we are taken here CD. Same similar way we have to take this portion as a AB. So this one is taken as AB. Then we are taking as a left one AB bar. So whatever we are taken in the column name, exactly similar way we are taking in the row side also. So what every cell become? Let's see. In this case it is 0001 1110, that is exactly here 0001 1110. So row and column exactly the same order we are placed. Now each cell what happens? If you take this cell, it is 11 here and 01 here. 1101, if you take this case 1101, we are calling as a 13. So it is called 13, or we can write 1101. Similar way we can write this one is 12. So it is 1100. Okay, nothing but it is a 12. 1100. Similar way we are getting this portion is 01 in the last part because LSB and MSB is 10. So it is 1001. 1001 is nothing but 9. So 9 is written this side. Similar way this is 8 because this portion is 10 and this portion is 00. So it is 1000. Similar way we can draw as a this 4 cell. Here very important to remember that, see, if you see here 4, 5, 6, 7 after we have to write 8. Usually we think that here 8 is come. No, actually after this 8 is coming into the last row. 8, 9 and 10, 11 comes. Then we are moving with the 12. So it is very important. Don't start 8, 9 in the third row. 8, 9 start with the last row. This is the one more trick in the KMAP. Once you understand this one, you can draw the equation. I hope you know how to draw the equation for each cell. So I will skip this part. Next we will move on the last 4 column. What is going on here? In the last 4 cell, we are taking this one as a 14. How it is 14? This row portion usually we are taking as a 1, 1 and column portion is 10. So it is 1, 1, 1, 0. 1, 1, 1, 0 is nothing but it is a 14. So we are calling this cell is 14. Next if I go, last one is 15 because row is 1, 1, column also 1, 1, all 1, 1 is 15. Similar way this is 10 because 1, 0, 1, 0, 1, 0, 1, 0 usually we call as a 10 from this part. Okay, so similar way this one is called 11 because 1, 0 from the row side and 1, 1 from the column side. So 1, 0, 1, 1 is called as a 11 here. This way we can make as a KMAP representation with respect to truth table. From this very important version we can make here, once you check this one, first one is 0, 1, then it is 3, 2. Same way 4, 5, 6 is here, then 7. Then usually we think 8 comes next. No, 8 is coming in the last cell. 8, 9, again it is 10, 11. So in this portion it is opposite. Again here start from last one 12, 13. After that 14 and 15. So you have to remember very important how KMAP is formed. It is not a similar way what we can call 0, 1, 2, 3, 4, 5, not like that. It is something like 0, 1, 3, 2 like that. If you already know about gray code, it is similar way of the gray code options. So we can move on the how to represent from the truth table to here. If I take one example here in the any KMAP variable 4, now we can take one example how to represent this equation into the our KMAP. If it is example A, B, C bar D, where I have to represent this A, B, C bar D. A, B means this portion is in the which particular column you have to check. That is in here we have third column. So AB we have to take this portion. Now we have to check corresponding C bar D. C bar D is the second one. So second column and third row. So this and this is meet. So this reasons we are calling as a 1 here. Similar way we can go with the AB C D bar. So AB is similar this portion only and CD bar means last portion. So this is CD bar and this is AB bar. So we are taking 1 over here. Similar way last one A bar B bar CD. A bar B bar is the first row third column. So we are going to this portion and this is 1. If you know about where you have to make one other portion, simply make as a 0. If you have to write 0, don't make it blank here. Okay. So this is how the representation of the KMAP for this equation. Similar way you can do for the sum notation also. If you take one more example notation, something called as a 15, 14, 6, 7, 3, 2, 4. It is actually very easy. 15 means where 15 is there, that is 1. 14 means the 14 here 1. 6 means we have somewhere here 6. This is 1. 7 means this is 7, 1. Then 3 is here, 3 is 1. Then 2 is here, 2 is 1. Then 4 is somewhere here, 4 is 1. This is how we can represent if it is somewhere in the notation form. And whichever not there, simply make it 0. Don't make it as a blank, fill it with zeros. This is how we can form the truth table using notation also possible. Now we can check how to draw from the truth table. Already I drawn here, just cross verify here. Wherever 1 present, first condition is 0, 0, 1. So it is 1 here. Same way, next it is 0, 0, 1, 1. 0, 0 means first row and 1, 1 is third column. For there you have to write. Otherwise, you have to go with these numbers 3. Very easily you can draw the wherever 3 present there. Next we have 4. So 4 is somewhere here. So this one is 1. Then we have 5. So wherever 5 is this one. So 1. Next we have 7. So this is 7. So this is 1. Then we have 10. So where it is 10. 1 minute. Yeah, this is 10. So you can write here. Then we have 12. So 12 is somewhere here, right here. And the last 14 and 15 both are present. 14 and 15 is these portions. From this truth table to KMAP possible. Once again remember, KMAP can be formed using 3 methods. Either from the truth table you can do the KMAP, or canonical equation into the KMAP, or some notation into the KMAP. Whichever they are given as a problem, from that you can form the KMAP. This is all about how to represent the KMAP we are studied. In the simple way, we can say that the KMAP plotted from truth tables with 2, 3 and 4 variables. Looking at the particular variable, we can having the output 1 have the corresponding cell marks with 1s. The other cells are marked with zeros. This is how we can draw the KMAP representation. Once you understand representation of the KMAP, then we can move on the simplified the KMAP, how the 2 variable look like, how 3 variable look like, how 4 variable look like. This is just a summary portion. Just memorize it. This portion we have taken MSB and this portion we have taken LSB. Already I told here we can take anywhere LSB and MSB. In example I have taken this side MSB and LSB. Also you can represent like this. Then this value becomes, this is 0 and 1, 2, 3, 4, 5 and 6, 7 opposite way. Both are correct. Whichever easy for you, you can go with that. And last one we are calling as a MSB LSB. If you are taking MSB in the vertical part and LSB in the horizontal part, then you will get different answer. So here also you can take in a other way, something like that. In this portion what happens, we have taken LSB this side, so it is 0 1 3 2 in this side. Instead of a row we are getting 0 1 2 3 2 there, here we are getting column. Both are proper representation, don't confuse with that. You can either take LSB as a row part or column part, MSB as a row part or column part, both are similar. Both simplification and you are getting same, so both representation are correct. Next we can move on the called as a how to do grouping of this cell. The second part in the KMAP, you have to do group from these wherever one present. From that only we can possibly simplify the equation. For this we can go with the step-by-step procedure. There is some rules and regulation for grouping. We cannot simply do any type of grouping. The first condition says that group may not include any cell containing 0. That means if you want to do grouping, it should be contained once. Here we have taken two examples. In this, the 1 is here and 0 is here. We cannot make grouping of this 0 1. This is wrong one. If it is 1 1 is present, the 0 here present, we have to make grouping of only 1 present. So we cannot make grouping of 1 zeros. That is the first and very primary rule and very important rule in the KMAP part. The second rule is that how to do groups. Group may be horizontal or vertical but not diagonal. That means you can do here either I can do as a vertical or we can do as a horizontal possible, but we cannot do something called like this diagonal. That is wrong. So rules is, first rules we can only make once. Second rule, either we can make vertically or either we can make horizontally, but we cannot do in diagonal. That is the second grouping rule. And third grouping rule, we can say that it is only possible 2 to the power of n cells only. That means 2 to the power of n means first one is 2 to the power of 1 means 2 cells. That is, if it is 2 to the power of 2 means 4 cells. 2 to the power of 3 means 8 cells. So number of 1, if it is 2 then we can do, or number of 1 is 4 we can do, or number of 1 8 we can do. Here the number of 1 is 2, so 2 number we can do, group of 2 possible. Then here all the part is 1, so group of 4 possible. And you cannot do group of 3, group of 5, group of 6, group of 7. These all are wrong. You can do group of 8 possible because that is 2 to the power of 3 possible. So third rule, very important. What is the number of grouping you can do it? The grouping number only possible for 2, 4 and 8. Other grouping it is not possible. Next we can move on the next rule. Each group how much large possible that we can do. This is somehow difficult. Just check properly. Each group should have a large possible. That means you have possibility of 2 groups and here 2 groups, but together if you have 4 groups. In previously what I told, you can do 2, 4, 8. If it is 8 possible, first preference to the 8 number of group only. If 8 not possible, then go for 4. If 4 not possible, then go for 2. If it is 4 possible, if you are doing 2, that is called as a wrong grouping. So always do maximum number of group. In this particular case, you can doing as a 2, 2 like this. This is entirely wrong. You can do something like this. Okay. Later I will tell you what is overlapping, how we can do overlapping. Don't worry about that. Now the fifth rule is very, very simple. Only you can take the first priority for making large number of groups. You cannot do small number of group when large number of group is possible. Now we can follow what is one must contain. See, in this particular portion, each cell containing a 1 must be in at least one group. That means at 2 to the power of 0 we can call as a part of 1. So the 1 also we can call as a simple group. And here also we can do these two number of group possible. Next group is group may wrap around the table. Okay, that is first one. Second one, the leftmost cell in a row may be grouped with the rightmost cell, and top cell column may be grouped with the bottom cell column. This is very important one. If you are taking this one here, and if it is one more here, you can take something like bottom here and top here. This is also possible. Same way, if you are taking left side also and rightmost also, this is called as a very important in the KMAP. If it is leftmost, rightmost, you can make it. Topmost and bottommost also you can make it, because it is a closed loop and that right and left are come together for the closed portions. So these are very important rule when you are doing as a grouping. Next condition, how to do group overlap. In the KMAP, we can make a cell may be grouped more than once. That means we can overlap, or we can make group it. Already group is there, still we can do another grouping is possible. But there is a condition. What is that condition? The group must have at least one cell that does not belong to any other group. If you are doing any new group, that new group should have one cell that does not belong to other group. One example, if you check, you will get to know what is exactly this means. If you are not done this one, the simplification of equation may changes and redundant terms will result different. If you take one example, this is 4 variable. Here we are doing one group like 1 in this type and another 1 this type. If I am overlapping and I am doing one more group, something like that, in this group it is 100% wrong. Why? Because in the red, whatever third group I have done, in these two, both are belongs to other group. So this group doesn't have unique one. So this group is wrong. To make sure that when you are overlapping something, one should be unique, that does not belong to any group. Once I will summarize that the first part is may not contain any zeros in the group. Second one, you can do horizontal or vertical, don't do diagonal. And group must be, it is 2 to the power of n cells, 1, 2, 4, 8. And each group should be large as possible. That means if it is 8 possible, don't go for 4, always go for 8 only. And last one, it is group may overlap. We can do overlapping is possible. Also group we can make as a wrap. Wrap means leftmost and rightmost we can make, and topmost and bottom also we can make it. Finally, grouping cells is nothing but once the boolean function is plotted on KMAP, we have to use grouping technique to simplify the boolean function. The grouping is nothing but combining term in adjacent cells. Two cells are said to be adjacent if they confirm the single change rule. That is, there is only one variable difference between coordinates of two cells. For example, the cells for min terms ABC and A bar BC are adjacent. Now we can move on the third and last part of the KMAP. Once we are done grouping, how to do the simplification of boolean expressions. So after grouping, from that grouping we can form the equation and we can do the simplification of that. Let's take example of one output simplification. If any expression have contain only one notation or one expressions of canonical equation, then how we can solve in the KMAP. In first example, we are taken summation of m 0. So summation of m 0 means the notation given 0. So in the truth table, wherever 0 point is there we are putting 1. and other all the portion 0. If you want to do grouping here, we know from rules 1, only 1 present, there we can do grouping. So we are doing only this portion as a grouping, other 0 portion no grouping. So if you want to take equation of this one, here the B bar, that is 0 present, and A bar 0 is present. So we can get as a K is equal to A bar B bar. This is the equation of the SOP form from this KMAP. If you want to form the POS form from this map, so we are getting as a K bar is equal to A plus B. If you take second example, in this we are taking as a summation m of 1. So it is 1 present. In the KMAP, if you are drawn, the 1 present means it is 0, 1. So we are taken 1 here. So only one group. In this we can call as a, our SOP form is A B bar. Why? Because A as it is, and here B bar is present in this particular group, so it is A B bar. If you want to represent same thing in the POS form, so wherever the A present, you have to write A bar, and plus wherever the B bar present, you have to write B, and equation you have to write in K bar. This is how we have to represent in POS. Similar example, if you take as a summation of M2. So in this we have to take wherever 2 is there, that is this point 2, there we are taking as a 1. All other portion is 0. If you form this equation, here B is 1 and A is 0. So A bar B. This is what SOP form we got from this group. And if you want to do it as a POS, simply opposite to the SOP. So wherever B bar is there, make it B, and wherever A bar is there, make it A, or if A is there, A bar, just opposite, and instead of multiplication plus, and output should be in the bar condition. This is how we can form the POS. If you take one more example, summation M of 3 means, so we are getting 1 in the 3 condition. So here A also 1, B also 1, so K is equal to AB. And if you want to K bar, so K bar is equal to A bar plus B bar. This is what POS form. Next we can move on for, if it is 2 output, how we can simplify the KMAP. Suppose I have taken one example. Here the first 2 case 1 1 is there. If you want to solve this one, what happens? This first condition, it is actually B bar, and the second condition also it is B bar. And if you want to take only this portion, so your equation is something called A bar B bar, what you have discussed previous part. So it is adding with the second part, that is B bar A. So here in this condition, actually we are getting equation something like that. In this, the B bar is common, so we are taking outside of the B bar, and A plus A bar is 1. So A plus A bar we are taking as something like that. We know that from the boolean laws this become 1. So our final answer is B bar. We can directly take this answer here, whichever the group is there. If it is 0 and 1 is there, we can cancel this one, only take which one is common here. This method we can use it. This is simple method to get the part. Next, take second one. If it is 1 1 present like this column wise, so what happens? Here the 1 1 means the both the part A remains same. So take A bar directly and ignore the B, because both the side B is there, B 1 and 0 is there, so you can ignore this one. Wherever any variable contain 1 and 0, you can ignore it. If anything contain only one variable, that you can take directly. That is the method to simplify in the KMAP. Next part we can take as a 1 1 in this direction. If it is 1 1 present in this direction, we cannot make any group. Listen carefully. So we have to make it individual group of 1 1. From this what happens? The 1 means it is A bar B bar. So we are writing A bar B bar as it is. This 1 actually the B is 1 and A also 1. So it is AB. You have to write as it is. This cannot be simplified because this is present diagonal. From the roots 2 we cannot make the group of diagonal ones. So as it is equation we have to write. Next portion, in this again we are taking 1 1 in other part. So this also a diagonal one. We cannot make it group. In this condition the 1 1 portion, this is A bar and B portion, and this one is nothing but A is 1 and B bar. So you care to take directly whatever equation present because grouping not possible. If grouping were not possible, simplification also not possible. Whatever equation as it is we have to take. Last condition, if it is 1 1 in something like last portion, so this grouping is possible vertically. So in this A is common, so take A as it is, and B has both 0 and 1, so B portion is cancel out. Practice like that. I have taken all the possibility of 2 output wherever it is possible. If it is diagonal, you have to get direct equations, and if you are getting as a group possible, there everywhere you are getting one variable, so simplification is possible. The same method, if you go with the 3 and 4 output simplification, how it works, just see it here. In this condition I have 3 ones. We can do 2 group here. The first group is something like this. In this group B is both side we are taking this group, okay. In this group B is 1 0, so B is cancel out and we are getting as a bar. Next, if you are taking another group, already we told that overlapping is possible if any one is unique, it not belongs to any other group. So this one is not belongs to any group, so we are doing overlapping also. In this case 0 and 1, so A portion get cancelled, we are getting as a B bar, so we can write as a B bar. So the final answer is A bar plus B bar. If 2 groups are there, then we have to use plus symbol because it is sum of product. If you take an next example, in this we are doing as a first group something like this. In this group what happens, B is 1 and 0, so B cancel out and we are getting as a as it is. Here again we are doing overlapping, and if you take this group, here in this group A is 0 and 1 both is there, cancel out, B is only 0, so we are getting B bar. If you take one more example, in this example here if you take as a this group B is 1 0, so it will get cancelled, we have A bar, so your answer is A bar. And second group if you are doing something like that, so 1 1 in the A 0 1 is there, both the A is present, so cancel it out, only B 1 portion is there, so exactly it is B, and plus is added in between this. This is the way how we can do the SOP form for this particular grouping. Next, one more grouping we can do. This is 1 1 and 1 this side. Here if I take grouping of this one, here B is 0 and 1 both variables, so cancel out, and I am getting this portion as a because A is 1 here. And second grouping I am doing something like that. In this the B is 1, A is contain both 0 1, so cancel out in the A, so we are getting B. It is called A plus B. This way you can do it for 3 variable possible. One more take example of 4 variable. If all variable is present, then what happens? We will do the 4 together. This is from that rules. Whichever large number is there, that we have to take. Here 4 is possible, then don't go for this one group, this one group. If maximum possible, go with that. So if it is maximum taken, B also both 0 1 is there, A also 0 1 is there, so A also cancel out, B also cancel out. This rule we are calling as a 1. If both the variable is cancel out, nothing present, then we call as a 1. This is how we can do the simplification of the variable. 2 variable I have done. Similar way you can do for 3 and 4 variables. Let's look at an example. Here is a simple truth table with 2 inputs, or shall we say 2 variable. You should recognize this at the truth table of an OR gate column. F contains the output value for each combination of input values A and B. Strictly speaking, this is the truth table for any combination of logic gates that behave in the same way as an OR gate. So we could say that this is the truth table of an OR function. That's why we call the output column F to construct the corresponding KMAP. We draw a grid with 1 square of each row in the truth table. The possible input value for A are used as column heading across the top, and those for B as row labels down the left hand side. These input values will act like coordinates for the output values. Now we can populate the KMAP. We can see from the truth table that when A is 0 and B is 0, the output is 0. When A is 0, B is 1, output is 1. When A is 1, B is 0, output is 1. And when A is 1 and B is 1, the output is 1. Our KMAP is ready for use. We will see that particular one again later. Now let's talk about how KMAP can be used to derive the simplest possible boolean expression. Here's another different truth table, again with 2 variables A and B, but the output in column F are different. This time the corresponding KMAP look like this is to derive the simplest boolean expression from KMAP. We are looking for the largest possible grouping of ones. An expression can be derived by inspecting this group. Here we can see that whenever there is a 1 in the group, the value of input A is 1. We can also see that the topmost one in the group corresponds to a value of 0 for input B. But the other one in the group corresponds to a value of 1 for input B. This means that the output is independent of the input value B, which makes a big redundant input. This grouping can therefore be expressed simply as the output of this function. Here is another example with 2 input. We have seen this one before. Is the truth table for an OR gate, but let's see how we can derive the boolean expression by inspecting the KMAP. Here the corresponding KMAP, a single group, cannot be I-shaped. So what we have here are 2 overlapping group of ones. The one in the vertical group always match the input value. The vertical grouping can therefore be expressed simply as the ones in the horizontal group always match the value B. So the horizontal grouping can be expressed as B. Hence, this KMAP represents the expression A or B. It is indeed